Hello everyone. Today we'll be doing question 22 on the 2024 AMC 10B or question 16 on the 2024 AMC 12B. The question reads as follows. A group of 16 people will be partitioned into 4 indistinguishable 4-person committees. Each committee will have 1 chairperson and 1 secretary. The number of different ways to make these assignments can be written as 3 to the rth power times m, where r and m are positive integers and m is not divisible by 3. What is r? So essentially what this problem is asking us is that if we find this number of ways to do so, we find how many factors of 3 are in this number. How many powers of 3 can we find once we figure out the factorization, if that makes sense. So let's find this number. Of course, we're not going to evaluate it because it seems pretty big, and that would be not ideal to helping us find the factors of 3 that exist. But let's see what we get, how we start, okay? So clearly, for the first group, there are 16 times 4 ways to choose the first 4 people. 12, choose 4 to choose the next 4 because we've already chosen the first 4. 8, choose 4 for the next 4 because we've chosen 8 already. And finally, 4, choose 4, which is simply 1, so I'm not going to add it for the last group. But we have to divide this by 4 factorial because the order in which these 4 groups are chosen doesn't matter. So like the people in these, so like for example, if we put A, B, C, D in the first group, there are 4 people, and E, F, G, H in the second group, it will be the same as if we swap the order in which they were chosen around. And since there are 4 factorial ways to order like the different groups once they're chosen, like the order in which they are chosen, we have to divide this number by 4 factorial. Now, we remember each committee will have 1 chairperson and 1 secretary. How many ways are there to choose the chairperson and secretary in the first one? Well, there's 4 times 3 ways, right? Because the roles are different, so the order which they're chosen does not matter, right? Does not matter. Order does not matter. I keep messing those up, but since there are different roles, you don't have to divide by overcounting, since if A is a chairperson and B is a secretary, it's different from if B was the chairperson and A is a secretary. So essentially, we do this for all 4 groups since it's all same, so it raises to 4 power. So how many factors of 3 are there? Well, notice how in 16, choose 4, what we actually have is 16 times 15 times 14 times 13 over 4 times 3 times 2 times 1. And since there's 1 factor of 3, which is over here in the numerator, and 1, which is here in the denominator, this ends up having 0 factors of 3. Because 1 divided by 1, all the 3's cancel out, so we have no factor of 3. Similarly, we have 0 over here, but we have 1 factor of 3 in 12 choose 4. Actually, in fact, we have 2 factors of 3. Why is this the case? Because once we expand this, we actually have 12 times 11 times 10 times 9 over 4 times 3 times 2 times 1. There are 1, 2, 3 factors on the numerator and only 1 in the denominator. So 3 minus 1 results in 2 factors of 3 for 12 choose 4. Clearly in this part there's 4, sorry. So in the entire numerator, I'm going to change the color to, let's do red. I'm going to show the entire numerator has 6 factors of 3. And clearly in the denominator it's 4 times 3 times 2 times 1, so there's 1 factor of 3. And once we divide it, we have 6 minus 1, 5 factors of 3. So the answer is 5. Thanks for watching.